Now we will be learning list. So Python list. In Python, we have a data type which is called list. It's a collection data type or multi-value data type. Now, how list look like? Let's take L as a variable, and I'm taking a list 10, comma 20, comma 30. So by this, you can observe that this is a list, like this is a collection data type where all these elements, these are all different elements which are like separated by comma and enclosed within square brackets. So it is like very easy to understand that when we are talking about list means all the variables, all the values are not the variables, values will be separated by comma and which will be enclosed by square braces. So this is what the definition. So I can take another list: 10, 2 plus 3j, false, python as a string. So as you can see here, I am taking in L1. L1 is another variable, another list variable where I have taken some elements which are different type of data type it is present, right? But here for L, only integer data type present. Now if a list is containing same kind of data type, then it is called actually homogeneous list. Homogeneous means same kind of data type, same type. Now this one, this L1 is actually called heterogeneous list. Now you can check the type of it, like if I take any value, like 3 value I have taken, now we are taking this enclosed within square braces. So check the type of it, type of L, what it is showing, class, sorry, type of L. So it is showing class list. Okay, so list is what, this list is coming, right? So this is what list is, the inbuilt name. Now is there any default value? Yes, default value it is also there. So what is the default value? How to check the default value? Just write the data type list, everything in lowercase, and use open close parenthesis. So this is what, this is the default value, which is actually called what, blank list. Blank list means there is no such space in between, it's completely blank. Now what is a default value? Means which is the value which is internally false. Now check, is it really internally false? So I'm just giving, I'm using here bool inbuilt function. So bool of this blank list, it is showing false. Now check bool of normal L, I have taken a L also, obviously it will be true, as because it is non default value, means only the blank list will be the default value, other than that all the list will be non default. So what is the definition, the formal definition of list? I'm just writing. So this is a list. List is a collection of homogeneous or heterogeneous elements where elements are separated by comma and enclosed within square braces. Okay, so this is the formal definition of list. Now, for as because it is a collection data type, so obviously we can understand the count of it. We don't have to count manually. We can use len, it is also an inbuilt function. So for list also I can use len because list is a collection data type, so len of L. So for L, manually you are counting 10, 20, 30, 3 elements are there, so 3 is the length of L. Now I'm just taking one example of one list. So this is one more list I have taken. So as you can see here, I have taken one list inside it as an element of this entire list. So for that case, it is actually called as, because this is also a collection data type, this is string, this is a collection, and even this is also a collection. So whenever you will be finding some collection inside a collection data type, this is what actually called nested collection. So for this case, it is a nested list. It is actually called what, nested list. Now how the memory allocation is happening, if you like, if you can visualize how this memory allocation is happening, it will be very easy to process further. Or if you want to write, like list is a type of data type which you will be using a lot of time in the programs, in normal programs we will be using lot of time. So understanding the list, visualizing a list or a complex type of list. Like this is what actually called 2D list, as because you are having a list inside a list, and this simple list is actually called 1D list. So if you can visualize this list by the memory allocation, it will be helpful for the future programming. Okay, so let's understand the memory allocation. And for this 2D list, if I ask you how many elements you are finding in this list, how many elements? So what is the count of it? 1, 2, 3, 4, and 5, 6? No, this entire nested list, it's a one element. Okay, so the count is actually 5. Now check it. L equals to, I am taking 1 comma 2 comma 3, and after that let's take one string which is python, and then I am taking one more nested list, 10 comma 20. So if you check the len of L now, len of L, it is what? It is 5, not 6. Because your nested collection, this nested list itself, one element of this primary list. Okay. So how this memory allocation is happening? First, let's understand simple thing. 1, comma 2, 2 plus 3j, true, and 3.5. So for this case, len of L is what? Len of L, let's take L1. Let's take this variable as L1. Len of L1 is what? As you can see, 5. Len of L1. So if I take the memory allocation, now on the same way, as because it is also going to store inside the RAM, so the memory is actually segregated into two halves, variable space and value space. Now which one will be getting stored first? Obviously the value, because you need, like, variable need the address of that particular value, right? Now, as because this is collection data type, and now here also order is important. This is ordered collection. Make sure you need to keep in mind this is ordered collection. So as because it is ordered collection, so you need a memory layer to store all these values. So we are again storing it in a memory layer. Now this layer, how many blocks, memory blocks will be there? As because five elements present, so five memory block. Like in the first block 1, then 2, 2 plus 3j, it will follow the proper order, 3.5, like this. And the random address of the first block, 0x12, that will be getting stored inside this L1, 0x12. You will be asking, as because it is order collection, is there like, can we give the sub address? Yes, of course we can give sub address, means indexing possible. Indexing possible. Why? Because order matters. As because it is ordered collection, so indexable, it is indexable. So on the same way we can do indexing. We can start positive indexing from 0, obviously 0, 1, 2, 3, 4, like this. On the same way we can go back with negative indexing, -1, -2, -3, -4, -5. And as because this list is containing only the single value data type, so it is very easy to store in single memory block. Now let's check how this you can access, like how you can access this individual elements. So I am taking this L1. L1 equals to, how it is, 1 comma 2 comma 2 plus 3j, then we have true, and then we have 3.5, 3.5. So this is what my L1 is. Now what is the accessing syntax for that case? We already have seen with index how we can access, where and then index. This is how. So what is the variable name here? L1. So I am using L1. Now let's suppose you want to access this true. So what is the index of true? It is 3. Either you can use 3 or you can use -2. So as because it is very right, so better to use with negative indexing. So L1 and L1 of -2. So what will be the result? See, true. Now this is how, if you want to access the last element, you will be using L1 of -1. So you will be getting 3.5. Now on the same way, if you want to use the first element, if you want to access L of 0, this is how you will be getting the first element. So this is how access you can access with the help of index. Now let's talk about this complex type of 2D list, like when you will be having this type of list, like when you will be having a list inside a list or a string inside a list, then what will be the memory allocation? That is very much important. So L2 I am taking. So let's take 1 3.5, and then Python, and then I'm taking one more on one more list, 1 comma 2. Fine. Now the thing is how the memory allocation, again on the same way, memory will be getting divided into two halves. One is variable space, and other one is value space. Now in the value space, obviously the value will get stored first. Now in the value space, first of all, let me ask you one question: what is the length of this L2? If I check the length of L2, what is the length of L2 here? 1 2 3, and this is one element. So 4, all total 4 blocks we need inside the memory layer. Okay, so 1 2 3 4. Now this is what one is, what single value data type, it is integer, so we can store inside a memory block. 3.5, it's a float, so it's single value data type. 3.5 you can store. Now Python, can you store this entire Python inside a single block of memory? Obviously no, so it is not possible. Now what is the solution for that? What is the solution for that? So as because this is a collection data type and you can't store this entire collection data type inside a single memory block, so the solution is that you need a secondary memory layer. So you will be creating one more, not you, actually the interpreter will be creating one more memory layer for this Python, like somewhere randomly. So Pyt, like Python is having how much length? It is 6, right? So 6 memory blocks, with that a layer will be created, and some random address, obviously it will be there, 0x13. That 0x13 will be getting stored here, not this entire Python, but the address of this nested collection will be stored. Now on the same way, this 1 comma 2, this is also one more nested collection. So for that case also, as because the length of this nested list is what, 2, so you will be getting a layer, secondary layer, with two memory block, 1 comma 2, some random address, obviously it will be there, let's suppose 0x77, that address will be getting stored here. Okay, and finally for the entire list, the main or the primary, this one is a primary layer, right? This is the primary layer, and this one is a secondary, this is secondary, and this one also secondary. So for the primary layer, there should be one address, 0x91, that will be getting stored inside this L2 variable 0x91, so that whenever you are going to check L2, you will be using L2 and L2 will be pointing to this location. Now we will be telling that then how this indexing will be going on, how to give the indexing. Now for this case also, for the primary layer, you will be giving the indexing like this: 0 1 2 3. Now the same way, -1 -2 -3 -4. Now for this nested collection, here also you will be giving indexing from 0. There is no such link with the previous one, so you have to start from 0, and again you can start from -1 for the negative indexing. Now in the same way, 0 1, and here -1 -2. This is how. Now the thing is, let's access them. Okay, so let's take L2. L2, I'm taking this L2, 1 comma 3.5 I have. Okay, after that Python, and then we have a nested list also, 1 comma 2. Now just verify what is the length of this L2. Length of this L2, what it is? 4. Clear. Now let's access the first element. How to do that? L of 0, because 0, at the 0th position we have this one, so I am getting this one. Now in the same way, if I want to access this Python, what I can do? What is the index of Python? Index of Python is 2. Either you can use 2 or you can use -2, any one of them. -2 also, if you go for, sorry, it is L2. L2, just a minute, let me correct it. L of 0, L2 of 0, we are having 1. L2 of 2, we are having what? Python. Now on the same way, L2 of, if I use -2, I can have this Python, right? So I can get this nested collection with the help of the index. Now this this address is the sub address of the primary layer. Now let's suppose I want to access anything from this secondary layer. Let's suppose I want to access this y now. What to do then? So for that case, I can access this L2 of minus 2. If I give, I can access this Python, right? Now if I going to get more detail about it, what is the index of y here? 1. So I can use double index here. For nested collection we can use double indexing. So for this case, let's go more detail. So what is the index of y? 1 is the index of y. So if I give L2 of minus 2 of 1, you will be getting this y. Now on the same way, let's suppose I want to access n. Let's try it. N. Let's suppose I want to access what? N. So first we need to go where? We need to go for Python. Now what is the index of Python? Obviously it is minus 2. So minus 2 means Python accessed. Now we want to access n. What is the position of x at the last? Means minus 1 is the index. Now if I go, n is my result. Now on the same way, let's suppose I want to access this 2 from this list. So it is inside the list. It is inside this nested list. So for this case, what we have to do here, we need to first access the nested list. So L2 of what? L2 of minus 1. This is how I can access the nested list. Now I need to go further more inside it. So L2 of minus 1. Now what is the location of 2 here? Location of 2 again minus 1. So L2 of minus 1 and minus 1, I will be getting this 2. So this is how you can do nested collection indexing. Okay, so double indexing you need to give. So this is how you can access, and I hope it is like I can clarify this by this visualization of this memory allocation. Fine, and still if you have any doubt, do comment me below. So this is all about list, but there is one more thing which is very very important, which is left. So let's talk about it. That is, if I give, like let's go back to L. So this is my L. Fine. Now we can do L of 0, and L of 0 will give me what will be the output. The first element it will return, right? Now in this place, let's suppose I want to change this 1 into 100. Is it possible? So if I use a new value after this, now check L, this is what the result is. Means the actual list is actually modified. So what will be happening here? If I want to modify, if I want to modify a list, what I can do here, L of the index, and then I can pass a new value and it will change. So as because like list is a collection data type which can be like where elements can be accessed plus can be modified. You can modify a list. That is why list is actually called mutable data type. Mutable data type means for this L2, let's take this L2. In the L2, if you are changing this L0 to 100, what will be happening in this block? This one will be override by 100. New value will come in this place. So in this particular location, you can change these values inside these blocks. You can change these values. That is why list is a type of data type which can be modified. That is why it is called mutable data type. Okay, so with the help of index, this is how you can modify a list. So what is the modification syntax? L of index equals to new value, you can change it. Now one more change I am just showing. Can we change inside the nested list? Yes, we can. Let's suppose we have this 220 inside this. Now I want to make it 2000. Is it possible? So for that case, let's access 20. How to access 20? We need to go inside this nested list. So first we need to access a nested list. What is the index of nested list? Minus 1, obviously. So this is how I can get the nested list. Now let's go inside this nested list, the last element. How to access the last element? Obviously, again, I have to give -1. Now this is how I am accessing this 20. Now let's go back to 20 and let's change it to 2000. Now check L. So it is possible. Now one more thing, let's change this Python to Python. Like in the place of P, I want to change C. Is it possible? Now check. So let's access P first. So what is the index of Python? So if, as because it is easy to understand its index from the right side, so it is -2. Fine. L of -2, you are getting Python. Clear. Now L of -2. Now let's go more inside this P. I want what P? What is the index of P? 0. So L of -2 of 0. I'm getting what? P. Done. Now that P I want to change to C. Now if I going to do that, equals to, I want to change this to C. Is it possible? No. What it is giving? Type error. Why? Because what it is telling, str object does not support item assignment. What we are trying to do? Modification. We want to do modification inside a string, but let me tell you important information about string, because that time string we have not completed fully. String is a data type which your element you can access, element you can access through indexing, through subaddress you can access. But if you're going to change it, string is a data type which cannot be modified. String is a data type which cannot be modified. Modification not possible. Once string is defined means it is properly locked. You can't change anything inside this. So this yellow color, this sublayer is properly locked. Okay, this is locked, fully locked. You can't change it. Anything you can't change to C. No, it's not possible. Because one string is ready means you can't change any element. You can only access them, but you can't modify them. So this phenomena is called immutable. So that is why string is immutable data type. Immutable data type. So what is mutable? Mutable means all, like that type of data type where elements you can access as well as you can modify also. But immutable data type means you can only access them but you can't modify. Once it is, like the memory is getting stored, means once it is, you like it is getting the memory layer means it's properly locked. You can't you can't modify them at all. So this is the immutable data type string. So that is the biggest difference between a list and a string, that string is immutable data type whereas list is mutable